Hello and welcome to this video on Rust programming. In this video we will learn about match keyword, but before we get into the match keyword uh, we will visit the problem which I failed to explain in last video. So first I will go get into that, and before we get into actual programming stuff, let me welcome all new comers to the channel. So if you are new to the channel, please subscribe to the channel so that you can watch more videos, and make sure that you hit that bell icon so that you can get notified about the new videos from my channel. So once that is out of the way, we now start. So if you look at intuitor's description, it says creates a consuming iterator, that is one that moves each value out of the array from start to end. The array cannot be used after calling this unless T implements copy, so the whole array is copied. Now if you see, this is our array, and if the values are moved, then we should not be able to use this array. Now this is an advanced concept that why this happens. I have not yet thought about moving the values in the Rust. So assume that the array does not have these values after into iter, then you can't use str. That is what the simple meaning of move means, that the value is no longer there. So you can't use str here. Now let me hit the Rust array thing, Rust array. So if you look at array, there is a trait called copy trait. So arrays implement copy trait, and that is why we did not get the error. Now what if we consider Rust vectors? Rust vectors. So if you look at vectors and you look at their traits, it does not implement copy. So if we use a vector instead of an array, then we should not be able to print the vector after it has been moved out of here. So let's see this program in action. I have already run it. Cargo run. So yeah, we can use the array after consuming the values. It does not get consumed actually, it copies the full array. The intuitor will copy the full array. But suppose this is a vector, okay? Then you see quickly Rust Analyzer makes this red. Borrow of moved value str. Value borrowed here after move at here, okay? So we can't use this. So the concept which I was talking about in my last video, that you can't move after one of the iter, intuitor or iter mute. The intuitor is the one using which you can't use the name after moving the values. So with this out of the way, we now focus on our this video's program that is called match. So let's comment this out. This example has come from Rust by example of Rust documentation. So for example, let me change the folder here. Let me increase the font for you. So we go to match and match. Okay. So this is a number I32. So what match does is it is more like switch of P. So if number is 1, it will print 1. If it is 2 or 3 or 5 or 7 or 11, it will print this is a prime. If it is between 13 and 11, including 13 and 19, including 19, then it will print 13. And for all other values, it will print int special. Now what is special about this is kind of default label of switch. So you have to provide this, otherwise Rust will throw error. In C, you can skip this, but in Rust you cannot. If I comment this out, it will complain. See, it starts complaining. All non-exhaustive patterns. So if you are giving I32, then you have to cover from int min to int max. All those values you have to cover. Otherwise, Rust will complain. It won't compile your program. Rust is very strict on compilation. If it finds a problem in the program, it just won't compile. So, and the second one is we have taken a boolean true. So if you match a boolean, you have to match against two values, true and false. And if if this arrow operator returns 0, then you can assign it to binary, 0 or 1. So it becomes a number. So this is essentially a conversion from boolean to a number. This is how you can convert. So let's see this program in action. Cargo run. So 13 was matching with 13 to 19, so it printed a teen. Let's say what happens if we say 1, then 1 will be printed. So you see it prints 1. What if we give it 3 or 5? Then it will print this is a prime. So you see it printed this is a prime. Now what if we give it something like 6? Then it will print int special, because it does not match the first 3 cases, it will match the 4th case. So it prints int special. So you can give it int max. But why int max is not coming? Int underscore max. Let me see. It will be part of integer constants. Int underscore max. stdu32, stdi32. Okay, I have to qualify with i32. Still not coming. Oh, it is just max, not int max. So if you want to see its value, it is given here. Okay. So now again it will print int special. It is not special. So this is how you use a match typically. When there is an enum, you have to match all the variants. When it is a number, you have to match the entire range. Of course, you can use the default value to handle all other cases other than what your program is concerned with. So this is how we do this. Now we see another program, which is match guards. So for example, let's look at the second example first. So second example, number is 4. Now if we match number, and if I is equal to 4, we say 0. And if I is greater than 0, we say greater than 0. And this is unreachable because it is unsigned 8-bit number. These two cases will cover all the use cases. But note that when a match guard is this is called match guard. This is called match guard, a condition which tests for some value or some range in a match arm. The Rust compiler does not account for match guards when it enumerates for the possible values of the value which is being matched, for the range of values against which it is being matched. So you have to use underscore here. If you comment this out, it will complain. Even though first two cases satisfy the or exhaust the entire range, still you have to give this. So match guards do not cover your ranges of the input. Now if you look at our temperature enum, it has two variants, Celsius and Fahrenheit. We take a variable temperature which is 35 Celsius. Now it is T greater than 30, it will say 35 degrees Celsius is above 30 Celsius. Now this is the match guard here. Okay, it won't match anything else even though we have exhausted everything. So even after this will complain. Okay, you have to give C is below 30 degrees Celsius, because greater than 30 is covered here, less than 30 is covered here. So note that we are matching only Celsius, but still you have to give the Fahrenheit variants to be compared with. So let's see this in action. So you see, tell me about 2147. Okay, I am in the wrong folder. Match guard. That is int max, which we have taken. So it says 35 C is above 30 degrees Celsius and greater than 0. So 4 is greater than 0, it will print greater than 0. So that is how match guard works. Now there is one more topic remaining with Match, that is destructuring different data types in Match, but that there will be a lot more examples in that. So I am stopping here, and I'll see you in the next video when we destructure different data types. So I hope that you have found this video useful and informative. Please make sure that you hit that like button and share it on social media as much as you want, and make use of the comment box to speak your mind. And I would like to interact with you guys, because some of you might be veteran programmers in other languages but new to Rust, or you may already be knowing Rust and may want to clear a doubt or two. So stay tuned for more videos. Thanks for watching. Happy programming.